Morning. Okay, so I think we're done with the Java methods. Um, so please actually start to work on the assignment and also the lab work. So you may experience some problem, but if you have any problem, just let me know. You can use the discussion forum to send any questions you might have. Okay, so we can, if I feel like we can discuss this in a class, it's a common problem, so we can discuss in the class. Okay, so today we're going to start the new topic, and I think that's the most important topics in Java. That's the object. Okay. Now, Java is called a language of object-oriented. So it's an object-oriented language. Now, why we call these language an object-oriented? Because unlike most of the traditional language, which is kind of procedure. So basically, you start the program, you start to run the code, and then do some jobs, and then you complete the job and you quit. Now, object-oriented programming, basically, you try to program something. You simulate some of the real objects and define its characteristics, and also define its behavior. Okay. Now the characteristics can be defined using the variable, and the behavior can be defined using methods. So we can define variables for the class for the class, and define methods for the class, and then we can actually perform these. And then so you can create an object for the class, and you know perform based on whatever you defined. So now before we actually continue, so we first need to know that what the Java syntax is. In Java, when we try to define any task or any operations, we first need to define a class. So we did not mention that, but if you look at the Java syntax for any Java program, we need to define a class first, right? So, and then the class name. Okay, so I call it my class. And inside the class, you're gonna actually define at least one method. That method is called the main method, and it's a static void main, and then parameters. And then you can define the method. And then inside the method, you can define variables, right? Int x, y, double a, b. So you can define an array. So you can perform all the operations. And also in Java, you're allowed to create some methods, other methods. It's a user-defined method. Say, okay, static. Let me actually erase that one because we're going to close the class later. So let's put it here. So a method says my method, okay, my function, or whatever I call it, my fun. So then you can pass the a variable, and you can define a variable like int x or double y. So also you can pass the Java array, right, as a variable, as a parameters. So you can always do this, and the method can return a value, or a method, doesn't have to return any value. But if a method are going to return an integer value, then you're going to put the int. And if the Java going to return an array reference, then you can put the int and the square parameter over here. Okay, so now let's assume that you're going to return just the integer value. So then you can actually define some local variable inside. It could be int p, q, whatever. So then you can perform the operation. Now, in this, Java code, we define a class and we define methods. Now, I did not particularly mention that so far, all the methods we define, we use the term, which is called a keyword called a statical. Okay. Now, what does that statical mean? We never explained this. Now, statical basically means, okay, I define a method inside this class. However, the reason I define this method, my fun, in the class my class, in this class called my class, it's not because this method has anything to do with this class. It's just because I define the class and I put this method in this class. Okay, I house this method in this class. Okay, but so the method itself has nothing to do with the class. I can put this my fun method in any class you want to put. So that statical basically means I just define a method in this class, but the method has nothing to do with the class. Okay, or the only relationship is the method my fun is defined in the class called my class. So when people actually call this class, if I call this method in the main method in this my class, and I can directly just call the method. Okay, so I can say x equals my fun, and then I can pass the argument. The first argument I can pass could be an integer. Second argument I pass it could be a double number. So it's a 2.5. It's a real number. So then I can call this class, and I can, in most of Java language, I can also define more than one class. Okay, so if I define another class, say public class, your class, okay, and then in your class, there's I can just say define a method, public static int, I return a value, and your method. And then in this method, you can actually call the method defined in my class. But in here, when I do it, I'm going to say, okay, int a, and then a equals my fun to 3.0. But when I call my fun, because I just call this my fun in another class outside this my class, so then because it's defined in my class, I have to put the my class dot my fun, because I have to specify my class in another class. Now that's the only relationship between the method myFun and the class myClass. It's just the myFun is defined in the class, but has nothing to do with the class itself. So I can define myFun also in your class, okay, as a statical method. So the statical basically means it is a method. I define a method for itself. The reason I have to define in the class called myClass is because in Java, everything has to be, put in the class. So when you write a Java program, you have to write the whole program in a class, and then you have to start the class. You have to start the program in the method called main. So main method. So main method is also a static. So that's you just define the method for the sake of method itself. But this method has nothing to do with the class. Okay. Now, when we talk about an object, then it's kind of different story. Now, that's the reason why in Java, class is so important. Okay. So class basically represent a group of objects with the same characteristics. That's the event. That's the purpose for the class. But so far, we haven't emphasized this. We basically just use the class as part of the syntax. Say, oh, Java, you write the Java program and you have to put the program in a class and whatever the class name is. So I can call any class name, right? Okay. So that's why in this chapter we can talk about the object. Okay. Now in programming, an object is a grouping of data and operation. Okay. So these data and operation can be performed on that data, and this operation can be performed on the data. Okay. So that's basically the object. And then how can we define the object in Java? That's something we can talk about. And before we talk about the object, then we actually talk about another terminology. It's called abstraction. Abstraction, you know. So abstraction basically means to have a user interact with an item at the high level with lower level internal details hidden from the user. Okay. So far, when we actually write the Java program, and then we define the variables and we define methods and we call the method. Okay. Now, can we actually do something like this? So how can we actually define, using Java to create something? I call this something object. We create the object, and this object has some characteristics. Okay. Or we also call these characteristics an attribute. And also, this object have some kind of behavior. Okay, so these are defined as a method. So now I don't care what this object is, but this object can perform some operation, perform something. Okay, and so we can ask the object to move, to fly, to do whatever we ask the object to do, as far as we define the object that can perform this behavior. Okay. Now, so in the idea in the abstraction, we want to, to create these objects. And so we can define all these methods in the object to perform, to actually perform these behaviors, to behave like this. So then we can program the object so the object can do such and such a job. And then the user, basically, the user of the object doesn't have to know how these methods are created. Okay, we don't have to know what's the details of this method, but all we need to know is, okay, so you tell me that you define a method in this object. This method is going to allow us to control this object to perform some kind of activities. So then the user can call the method to perform these activities for this object. Okay, so that's called abstraction. So we can actually create the methods, and other people can call this method to perform some kind of tasks. But the people who call this method doesn't have to know the details of the implementation. So they don't have to know exactly how these methods are created. They just need to know what this method is going to perform. Okay, so that's called abstraction. So we want to have, this kind of, we can code the program like this. So we don't have to know the details of the object, but we can actually manipulate the object based on the methods they provide. So this is called abstraction. Okay. Sometimes this is called information hiding or encapsulation. Okay. Now, this abstraction has happened, in our real life. One of the example is, for example, like an automobile. So if we have an automobile, we have a car. So then we actually, once we actually sit in the car, we know, oh, this is a transmission, and this is actually the gas pedal, so we can accelerate. We can start to actually, when we press the gas pedal, the vehicle start to accelerate and start to run. Or here's the brake. So I'm a driver of the vehicle. I can control the vehicle to perform whatever the things. I can drive, I can drive backward, I can just turn right, I can turn left. I can actually operate the vehicles. However, I don't have to know how each of the components is working, like a transmission. Do I have to know how the transmit works? All I need to know is this is a transmission. I can just shift the gear so I can perform various different activities. I can drive forward, I can drive backward, I can just turn, I can actually, stop the vehicle. So I know the transmission can actually gonna be able to do that. That's a kind of abstraction, right? So we can treat your car as an object and treat the transmission, gas pedal, brake as the interface, the methods. Okay. So that's the abstraction. And we hope that we can create a Java program who actually act similarly like this. Okay. So objects strongly support abstraction. So we want to create the object that we want to tell people what does this object supposed to do. And then we can tell people how to actually control this object to perform these things. Okay. So based on this, we hope that we can create object using Java language. Okay. Now here's another term, abstract data type. An abstract data type, ADT, is a data type whose creation update are constrained to specific well-defined operations. Okay. A class can be used to implement an ADT. So class is not just a part of the syntax for the Java. So in order to actually perform the Java operation, we have to define the class and put the main method, and then we can just write the Java code in there. That's just the one purpose. The more important reason we create a Java class in Java is we want to actually implement the ADT. Okay. Now, how can we use the Java to define to form object? Okay. So the class constructor defines a new type that can group data and a method to form object. So when we define a class, we basically define a new type. It's just like a string, just like an integer, just like a double, and now we can create our own type. And what is this type? It's whatever you define this type to be. Now, how this type can behave, it depends on what kind of data, what kind of variables you're going to define in this type, and what kind of methods you're going to be implemented in there. Okay. So when we define a class, now we need to define some member methods, and these member method has to be a public member methods. So it's because it's public, so everyone can actually call these methods, but it's a member method. Okay. So a class's public member methods indicate all operations a class user can perform on the object. Okay. A class also has private fields. So private fields are basically variables that the member methods access, but the class user. Member methods can access, but the class user cannot. Okay. Now the power of the classes is that a class user need not to know how the class data and the methods are implemented, but need only understand how each public method behaves. Okay. Now let's see. We can define a class. We can define a class. We can define a method in a class called member methods, a public member method. Now, what's the difference between public member methods and the methods we define here, like a statical method? Statical, my fun is a statical method. It's even though it's also a public, so you can call this method, but it's a statical. So that means it's not a member method. So this method has nothing to do with the class. Okay. Now, how are we going to define this? Okay, I'll be back, and let's actually finish a couple of slides, then we will be back and with an example. So a programmer can create one or more objects of the same class. So we can define the class first, okay? And then with this class, we can create an object for this class. We can create another object for this class. For example, if you take a look at the type called a string, you can interpret the string as a class. Okay. Now, when you declare a string variable, say my string. Now, that's an object. It's an object of type string. Now, you can define another string, right? String, your string. So when you define a string, the Java are going to create, reserve a memory space. That space is going to actually reserved for this string. And then you create your string, the Java are going to actually reserve a memory space and for this. And then my string and your string are different objects. They're completely different. They'll be actually located in different memory location. So you can assign a value to my string. You can say my string is, okay, I can call it Brady. That's my string. And your string, I can call it CSC. Okay. So then I can put the Brady here and the CSC here. So these are completely actually object. But these two things are the same type. They're both of these are string type. Okay. Now, so then with a string, you can use all these methods created for the string. That's the method. It's called member method. What's the member? It's a member of the string. Okay. So now the purpose for the class is to create the class which is similar to the string, and then we can create many different objects of this class. Okay. So to create an object consists of two steps: declaring a reference variable of the class type and assign the variable with the explicitly allocated instance of the class type. Okay. Now we can talk about this a little bit later using example. Okay. So a reference variable can refer to an instance of a class. Okay. The new operator explicitly allocate the object. So this basically tell you how to create an object using reference variables. Okay. Now, for example, if I create a class called a public class I call a car. Okay. So then you can define all the class field. Class field basically it's the attributes. So you can say what is the year of the car, model of the car, or whatever. This basically used to characterize a particular vehicle. And then you can define methods or behavior. So the car has a method called stop, a method called run, a method called reverse. Okay. So you can define various different methods to control a car. So you can define a class called car. And then to create the object of the car, you can say car, just like a string, right? My car, okay, equals new, use the new operator, and then I can say car. So I create an instance of a car. And then you can call this again car. Your car equals new car. That means you create another object for the car. So then each of the object, my car, your car, are different cars, but both of these are car. So they belongs to the same type. Okay. So when I call a method in my car, I'm going to say my car dot whatever the method name. So let's actually take a look at the example. Okay. So here I create a class called restaurant. Okay. And the restaurant has, I define two field or variable. One is restaurant. I declare a name. It's a type string. And also I define another variable called rating. It's an integer type. Okay, so these are two variables related to the restaurant. Okay, now we put the private here. Don't ask me why at this moment. I will explain later. Okay, and then we define a couple of methods. One method is called set name, set rating, and then one method is called printer. Okay, now set name basically is a method defined for the restaurant, the class restaurant. So then I can set a name of this particular restaurant. Okay, now what the set name gonna do? So when I call a method called set name for this restaurant, I need to provide a name, right? So I'm gonna name this restaurant McDonald's. I'm gonna name this restaurant Domino's Pizza. So then I need to actually once I create an object of the restaurant type, then I'm gonna say what is the name of this particular restaurant. So the object basically represent a particular name. The class restaurant basically represent a group of things called a restaurant. Okay, so these group of things should have the same characteristics. So for example, if we talk about a general restaurant, a restaurant should have a name. A restaurant should have a rating. So when I actually try to go out to eat, I need to check each of the rating of each of the restaurant. I always choose the restaurant with high rating. The rating could be rated by the customers, right? So, and then when I create the object, I need to set a rating. Okay, 3-star, 5-star, 2-star, 2.5 stars. Okay, so here the rating is integer, so you cannot have a 2.5. Okay, so then I can create an object, a method called a printer. Now remember, when I create this method, there's no keyword called a statical anymore. There's no statical. So that means these methods are the member methods. So these methods belongs to this object called a restaurant. Okay. Now you might still be confused, but don't worry, we'll get there. Now once you define a class called a restaurant, now how can we use the class restaurant? And then I can define another class called the restaurant favorites. Okay. In the restaurant favorites, I just define a main method. It's a public static void main method and a string args. Okay. Now, in the main method, I want to create object of the restaurant. Okay. So I create a restaurant called object called a fave lunch place. So I want to create a restaurant object called a fave lunch place. It's my favorite lunch place. Okay. And this is actually it's an object of the restaurant. So because I defined a class called restaurant, so I'm gonna call restaurant here. Restaurant fave lunch place equals new restaurant parentheses. This sounds familiar, right? Because if I actually try to define my string, I'm gonna say string, my string equals new string. Now, instead of string, I replace with the class called restaurant. So I replace with restaurant, my fave, a fave lunch place, and new restaurant. So restaurant, restaurant. So so you basically use the class name the same way as using the string. Okay, string, actually string is a class, but the string is a class which is defined by the creator of the Java. So they put the string class in the library, in the Java library, because string is a very popular class. So everybody wants to use the string feature. So that's why they put this string in the Java library. So when we try to use a string, you don't have to create the string class again and again. So that's called a library class. But now I want to create my own customized class. It's a user-defined class. Now, once I define this restaurant, my favorite place, new restaurant, I create an object of the restaurant. And then I want to say, first I want to set a name, set a rating. So I want to say favorite lunch place dot set rating. So basically I call this method called set rating. But when I call it, because this is a member method, so that means this method is particularly related to the object of the class restaurant. So I'm going to use the object name, fav lunch place dot set rating. So that means for this particular restaurant we're talking about, the rating I will set to 5. Okay. So now let's actually take a look at the example. So let's actually go to the repel IT so we can see how we can actually run this code. Okay. Let's see. Okay, here we go. Okay. So I defined a class called a restaurant. Okay. And then I have two extra field. And one is the name, which is it's a type of string. The other one is rating. It's a type int. And then I define a name called a public name. Okay. So I just enlarge the space so we can actually clearly see the code. So the set name is actually, you're going to take the parameter called the restaurant name, which is a string type. And once I actually pass the restaurant name and assign the restaurant name to the name of this particular. So every restaurant has a name, okay? But for each object, the name is different because once I actually define the object, say my restaurant, your restaurant, my favorite lunch place, my favorite dinner place, or whatever you call, you declare each of the object of the restaurant. And then you can actually provide different names by calling the set name, okay? And then set rating, and then print. Okay, I create a method called print. So the method basically gonna actually do is I'm gonna print the name of the restaurant, and I'm gonna print the rating of the restaurant. Okay, so that's the class called restaurant. So I define a class with the field name and methods, the member methods, and then in the main method, which is defined in another class called restaurant favorites, I actually in the main method of this class, I define two objects of the restaurant. First, restaurant fav lunch place. The other one is called fav pizza place. Okay, so it's my favorite pizza restaurant. So then I'm gonna declare the two object. Okay, now for my fav lunch place, then I call my fav lunch place dot set name. which is the method defined in the restaurant, right? Set name. And I provide my name, Slattery, okay? And I put the setting rating. My fave lunch place set rating is 5, okay? And then I actually call fave lunch place and call printer, okay? And then for the fave pizza place, I say fave pizza place dot set name. I just actually put the name, say not your average Joe's, okay? That's a restaurant name. And I put the setting is 4, the set rating is 4. And then I print the information I just provided. Okay. So let's actually just run this code. I'm going to say Java C, and that's the compiler, the command line compiler I use. Restaurant favorite, okay, FAVORITES Java. So this is also the name of the file, right? Restaurant favorite.java. Okay. Okay, let me actually put this part larger so you can see. Okay, so now I'm gonna run this code. Java space restaurant favorite. Okay, so I call this method, and then it's gonna print out. So basically, I declare the restaurant 2 objects: fave lunch place, fave place, and then I assign the slattery to the fave lunch place. I put the rating 5 to the fave lunch place. So, and the fave lunch dot print. This is gonna print out 2 lines, right? So the first one says the restaurant is slattery, and the restaurant rating is 5. And the second one is the favorite pizza place, and then the restaurant name is not your average Joe's, and the restaurant rating is 4. Okay, so basically I created 2 objects of the restaurant. First is my lunch place, the other one is favorite pizza place. Okay, and then I put the name Slattery for the favorite lunch place, and then put the rating 5 to the favorite lunch place, and then I print the favorite lunch place because I call the printer in this favorite lunch place, in the favorite lunch place, the favorite lunch place dot print. So that means I call the print in this for this particular object. So any questions on this?
So far, no.
Okay, that's good. Now, if you don't have a question, let me ask you a question. Now, in class restaurant, we define 2 field variables. One is string, the name of the type string. The other one is rating of type integer. Now, I put a private here. Okay. Now, here's my question. Can we put this as a public? Let's say that means this variable string name I make this a public name.
You should be able to.
Okay. Let's say I change the name to be a public. Okay. and I still keep the rating private. So let's say, let's compile it. Okay. You compare the output of these two. Doesn't seem like there's any difference, right? Now, what's the difference between these two? Okay, because that's important. Now, if we put the public, so that means this name can be accessed publicly outside the class object. Okay, so then now in this code, I basically create a two field variable, name and the rating, and I set up the value name through the class called, or through the method called set name, right? So I set the name and I provide a name, and then in this public method called set name, I actually set the value for the name. And this set name can also change the value of the name. So if, for example, if I initially set my favorite lunch place dot set name, I put a Slattery, and then I find out, oh, I find a better restaurant, better lunch place than Flattery. So then I'm gonna say, okay, I'm gonna change this. Okay, so I can say my favorite set name. Okay, now I change it. I change it to um. Let's check. Let's find a restaurant. Okay, I called whatever. I just what do you think? What's the name you should actually put in there? Okay, let's say Hard Rock. Okay, say this. I set a name. Okay, so I call the favorite lunch place dot set name again. Okay, but I don't change the rating. So let's just print this again. Let's say what I'm gonna do is call system dot out dot print after the name change. Okay, now let's do this. Okay, the restaurant name is Slattery, rating is 5. Restaurant name, that's the pizza place, not my favorite Joe. The restaurant rating is 4. And after name change, the restaurant name is Hard Rock Restaurant, and the restaurant rating is 5. So I changed the field variable name from Slattery to Hard Rock Restaurant for the object favorite lunch place. Okay, for favorite lunch place, I changed the name. Now, what's this has anything to do with public or private? Now, if the name is defined as a public, the field name is defined as public, then I don't have to use the method. I don't have to use the method call. I can basically use, I don't have to use a set name. I just directly use the assignment. I say favorite lunch place, that's object. Okay. Now in this favorite lunch object, which is type restaurant, and in this one I have a field variable inside actually class called restaurant, the name. And the favorite lunch place is an object of restaurant. So then the restaurant has a name, a, you know, has a variable called a name. So let's say, can I actually directly just say, okay, A and B. So I directly call the name favorite lunch place dot name, just like a favorite place dot set rating, set name, because it's public. So I can directly call the name, and I can directly change it, okay, to Hard Rock. Okay, directly change the name. So I just say favorite dot name, which will be assigned a new string called Hard Rock. I compile it again. I run it again. So that I can actually change the name, right? I don't have to call the method to change the name. Okay. Now, can I do the same for the rating? Because rating is also a field variable, right? Okay, I see Alex just type and say no. Yeah, let's check. Okay, rating, and I'm gonna say I want to change to 5. Okay, it was actually 4. Oh, slightly, it was. I changed to 4. Okay, it was 5. Okay, the answer is no. Let's clean that up. So let's say Java C C. Uh, okay, I got an error message. Don't be scared with error message. It says restaurant favorite.java 17. Let's take a look at 17. Yes, that's 17. Okay. Rating has a private access in restaurant. So because it's a private, so I cannot directly access the rating by calling favorite lunch place dot rating. Okay. If I want to change the value for the rating, I have to go through the public method. Okay, the member method, like a set name allows us to change the, oh, I'm sorry, the set rating allow us to change the rating. Okay, but I cannot directly change it using this. Now, then you may ask, well, if you cannot change it, why just to change the rating to public as well, right? If I change to public, then it should be okay. Okay, now that problem disappeared. Fine, right? It's working. I changed the rating as well. Okay, after the name change. Now, here's my question. Can we actually change all the field variables to public for a class? technically it's okay, right? I don't see the reason why not, because it works. However, there's one problem. What is that problem? Let's go back. Now, remember the slide we say we want to achieve the abstraction using Java object. What does objection means? Okay, so that means when I create an object, the object has many characteristics. Okay, now, so what I want is I want some kind of encapsulation, which means if I define a variable here, x, y, z, these are all the variables I define. I only want the people who to access these x, y, z variable from the interface, from the method. Okay. So if I want to change the value of x, you have to go through a method. Okay. So in this particular case, restaurant case, if I want to change the rating, you have to call a method called a set rating. If you want to change the name of the restaurant, you have to call the method called a set name. Okay, that's the interface provided to the user. And I want to hide the actual details of the information. So people cannot randomly just go outside and directly change it. So if you want to change them, go through the method. You cannot directly change it. If there's no method allow you to change the name, that means when people create the object, they deliberately want to actually keep this private. They don't want other people, the object, the class user to change the name. If they don't want you to change the name, a particular variable name, and then they make it private, and they did not implement a method to change that name. Okay, if that's the case, that's actually the purpose for the from the designer. So they just didn't want, they don't want you to change it. Okay. Now, however, if you define all these variables, the field variable as a public, then you have no control of this. Everyone can change the name of this restaurant. Everyone can change the rating of the restaurant because they don't have to go through the interface. Okay. Now this is just like you know, like a warehouse. So you have a lot of different products in your warehouse. Okay. Now, in order to make the warehouse like manage the warehouse, control this warehouse, you can provide a front desk. Okay, a front desk. So if you want to actually say, I want this particular product in aisle number 5, there's a TV. Okay, so then these aisles in the warehouse are private. Okay, so the customer cannot get into the warehouse and take the TV by themselves. They have to ask the front desk people, say, I want this particular TV. And the front desk people can go over to the aisle and pick the TV and give to the customer. Now, so if you actually create something and then you hide the details of the warehouse, okay? So in this particular warehouse case, you don't even need to tell the customer, so the TV is in aisle 5, because the customer cannot go into the warehouse, right? They only actually ask the front desk and ask the service people, say, I want a restaurant, I want a TV, okay, of particular model. And then they just go in there and pick the TV for the customer. So they don't have to release the details of this warehouse. So that's the encapsulation. Now, if you actually make the aisles public, then you violate this encapsulation rule. So that's a reason why you don't want to make these things actually public. Okay, so the name and the rating should be private. Okay. Any questions on this?
No.
Okay, let's talk about another example. Just illustrate that the concept of the. So let's actually create a class called bank account. So when we create a class called bank account, and then you need to define what's the class fields. So what a bank account should have, and what's the methods the bank account should provide. Okay. So when we create the bank account, what kind of field do you think we should have? A bank account should have, in your bank account, just think of whatever the bank account you have. You should have a bank account.
A savings account?
Okay, you can say savings account. When you actually say savings account, you're actually talking about the savings account balance, right? The amount of money in your savings account. Okay. Right?
Yes.
Okay. So let's actually put this aside. Let's say I'm not going to actually directly create a field called savings account. I'm going to create a field called my account balance. Okay, that's the one I want to create. What else do we need? What else do we need?
A name or member ID?
A name. Yeah, that's true. A name or member ID. Account. Or I can say, let's say account owner, right? So who owns the
Yeah.
account? Account owner. Or we also need something called account ID. So that's basically, account ID is something that the bank actually need to create. So they can randomly assign a number, unique number to reflect your account. So your account has a unique account ID. So for this particular bank, if your account ID is 9750, and then 9750 basically represent your account. No one else can use the account ID in this restaurant, right? Oh, no, I'm sorry. I'm still thinking about restaurant. We're talking about the bank now. Okay. Now, back to the questions you mentioned that when you say why I don't want to put a savings account in the class field, I think a savings account could be because it doesn't matter whether it's savings account or your the other whatever the account you have. So you can treat savings account as an object for a bank account. So because savings account has account balance, account owner, account ID, and then you have another account like an investment account or whatever account you call it, and then the account has balance, owner, ID. So then you can create a savings account or investment account. You can actually view these as a different object for the bank account, right? Instead of actually a field in a bank account. The bank account basically just talk about just one account. Now, what about the methods you want to define? I want to do the deposit, right? I want to perform the deposit. So what the deposit is going to do is, when you do the deposit, you need to provide a parameters. So that, okay. So that means you need to provide, okay, the amount of money you want to deposit amount. Right? What the other operations you want to, the methods you want to create?
Withdrawal.
Withdraw. And also, you want to tell how much you want to withdraw, right? Amount. Deposit, withdraw, and sometimes I want to check a balance. So I'm going to call get balance, right? Right? So when I say get balance, I don't have to provide anything, just to get balance. Okay. So these are the field, these are the methods. So I can create my, create a class called a bank account. Okay. Anything else you want to add?
Possibly a transfer balance between accounts.
Transfer a balance between account. Okay. That's actually a very interesting question. You say transfer. Okay. Now,
Like if you have a checking and a savings, but you want to put stuff from your checking into your savings.
yes. Now, definitely we can do that. But here, there's a problem. Because when we create a bank account, we're talking about create the object of a bank account. I'm talking about a particular account. Say, I create a bank account class, and then there's a balance, owner, ID. So this is we are all talking about a particular bank account. Say, I created my object. That means my bank account, John's bank account, Mary's bank account. So at this moment, I want to create a method that these methods are basically used to manipulate all the account information. Now, you actually bring up another interesting question that if you actually create a bank account, I say my account, my checkings account, right? Okay. So my checking account, and then it's a new bank account, and then you can create another bank account, say my savings account, and a new. So you're talking about transfer the amount of money from my checkings account to my savings account. Okay. that's a very interesting. So yes, it's doable. So we can say, okay, so let's say transfer. Okay. So when I define a transfer, then I'm gonna say first I need to define how much, what's the amount I want to transfer, right? And also, what other information I need to provide?
Where you're transferring to.
Where you're transferring to. And that could be another account, not this account, right? So then what you're going to do is you're probably going to actually include another bank account. So I could say other account as parameter. So transfer basically say transfer amount to another account. What's the other account? Bank account. It's a type of bank account, but it's other account. And then how we can operate this? That's a very interesting question. So we can actually talk about this next time. Okay. We can talk about this on Monday about how to implement this bank account. Okay. So I'm gonna stop right here because we are running out of time. But this is actually a very interesting question. But we definitely can implement a method so I can transfer the money from the current account we're talking about to another account, to add this amount to the balance of another account, right? So in that case, we can write the program. We can create the two accounts, my checkings account, my savings account. And then when I call a method in my checkings account, I can just say, I want to transfer certain amount from my checkings account to my savings account. How is that? Let's talk about this next time. Okay, so any questions before we call it a day?
Not the moment.
Not the moment. Okay. So think about this. Okay. Even you can think about how you're going to implement this bank account. Okay, you can share your ideas. So you can, if you have any questions or you want to share anything you have done, you can use the discussion forum on the Blackboard. So okay, so let's talk about this on Monday, so we can continue to work on these bank account things. Okay.
Have a good weekend.
Have a good weekend.
Have a good weekend.
Yeah.
Have a good weekend.